Namaskar, welcome to the second lecture of complex integration. So, in the first part, we have discussed about Jordan arc, Jordan curve, winding number, closed curve. Okay, we have also discussed that which are the property that cannot be carried out in complex analysis. Okay, कि ऐसे कौन कौन से प्रॉपर्टीज हैं जिसको कि हम कॉम्प्लेक्स एनालिसिस में सीधा नहीं खींच सकते कैलकुलस वगैरह से. ओके, जॉर्डन आर्क, जॉर्डन कर्व, क्लोज्ड कर्व, इस सब से रिलेटेड जो भी बातें थी उसको भी हमने डिस्कस किया था. इजंट इट? यस. And you can check the playlist of this channel. Okay, you can subscribe and share also if you want. Okay, so now let's go to a start. Actually, in this lecture I have decided to introduce you with some contour, its reversal, okay, many things related to that. But क्या हुआ कि when I saw this question, जब मैंने ये क्वेश्चन देखा, then I decided कि we should discuss some line integrals. Okay, before doing integrations on the curve or on a contour, first of all, let's enjoy some line integrals in complex analysis. Yes, this lecture is dedicated for this. Line integrals in complex analysis. All right. And do you know what is the beauty of this lecture? Yes, we are going to introduce you with a line integral with the help of a CSIR net 2019 questions. So this is the beauty. Okay, so let's go to read the question. That given a real number a greater than 0, consider the triangle with vertices 0, a and a plus iota a. Okay, so a beautiful triangle is over here. So why you are not trying to make the picture? So here is 0 and here is a, and if you want to write a plus iota a, then you have to go over here. Okay, along x-axis a, along y-axis a. So this is the point a plus iota a. Okay, simply you can write it as a comma a as well, isn't it? So now this is the triangle. Over this you have to integrate, and okay, counterclockwise this thing is also written, so we must have to put the orientation anti-clockwise. Now you can see that this triangle has three sides. Let's call it c1, let's call it c2, and let's call it c3. So we have to perform this integral over the triangle, real part of z dz, over the first curve, over the second curve, and over the third curve, isn't it? So first of all, let's go to integrate it along c1. Okay, so yes, first of all, let's go to integrate along c1. Okay, but moving along c1, before moving along c1, you should write one thing: z of t is equals to x of t plus iota y of t, because parameter used to help you sometimes, okay, to write the upper limit, lower limit, and all these things. For example, if you are moving from 0 to a along x-axis, then what will be your y along x-axis, or we can say along c1? Then you will see your y is going to become 0, isn't it? And along this x-axis, certainly this x varies. Okay, so you can take the real part of z as t. People will say, oh, we should write x, but don't worry. If I am writing t, however, we are moving on x-axis only. So notation is just notation, because we are going to form a definite integration. So let me write real part of z is equals to t, no problem. Now, what are the limits? T lies between where to where? Certainly from 0 to a, isn't it? So now along c1, if you want to perform the integration along c1, okay, real part of z dz, then how does it look? Certainly it's look like 0 to a, Okay, real part of z is t dt. हो जाएगा कि नहीं, 0 से a t dt. All right, so from here what can you see, it is t square by 2 from 0 to a. ठीक है, टी स्क्वायर बाई 2 फ्रॉम 0 टू a, ये चीजें हो जाएंगी. अब यहां पे कहोगे कि why you have taken dt right here. So if I would like to tell you that if your z is equals to t, if your z is equals to t, then dz can be written as dt, no problem. So that's the reason. And yes, you people will not hesitate to see this as a square by 2. So yes, along C1 you have obtained your integration as a square by 2. Right? Now let's go to move along this curve C2. Okay? So along C2, what can you see? Along the curve C2, what can you see? You can easily see that this is the curve. Okay, how shall you write your z? Your z will be what? Your curve will be what? A plus iota t. Are you people agree? A plus iota t. Yes. Why? Because you can see this, you are at a, x is equals to a. Okay, x is equals to a, and your y is moving. You are moving along this vertical line. Okay, so certainly y varies, and from where to where? So certainly you can see y varies from y is equals to 0 to y is equals to a. That's why once again the limit is going to become, so certainly if you are using this parameter t, then certainly you will take t from 0 to a for simplicity. And if you will find your dz, then it will become its derivative 0, but its derivative I dt. So now along C2, the real part of z, dz will become what? What is the real part of z? A. Okay, what is dz? Iota dt. And what is the limit from 0 to a? So what the thing will happen? A iota into t from where to where? From 0 to a. So finally you are going to see this as how? You are going to see this as a square iota, isn't it? So yes, along C2 we have obtained. Now first of all, we have to calculate our integral along C3. So from here to here. But for now let's put the name over here. Let's call it A. So we have to find the integral along AO. But for simplicity, we are taking OA as the curve, and whatever the answer will come, we will change their sign. So first of all, let's find the integral along OA. Okay, for C3, I would like to say, okay, we'll change the sign at last, don't worry, because the orientation is anti-clockwise. Your orientation is anti-clockwise, but we are seeing in the negative opposite direction from 0 to a. So along C3, if you will change the negative sign, then everything will be okay. So yes, for C3, what can you see? Your z of t will be what? T plus iota t. Why? Because here in this case, you can see actually you are moving along y is equals to x. Okay, so if your x is equals to t, then y will be t as well. Okay, so your z is what? T plus iota t. Your z of t is what? T plus iota t, right? And now what the thing will happen? You have to get the integration along C3. So you can also see that from 0 to a, what are the coordinates? 0 to a only, isn't it? From where to where you are going to integrate? From 0 to a, isn't it? So your integration will be what? Along C3, and certainly you need to find dz. So your dz will become what? 1 plus iota dt. This will be your dz. Okay, and real part of z dz will become what? So hence we will take negative sign. Why negative sign? Because what is your c3? Your c3 is in anti-clockwise direction, but actually we are integrating from 0 to a. So certainly we have to take the negative sign there. So negative sign, all right, over c3. So c3, therefore it will become 0 to a. All right, and what is the real part of z? The real part of z is t. And what is dz? So 1 plus iota into dt. So it will become what? 1 plus iota into, okay, t dt is there, so t square by 2 from 0 to 1, isn't it? From 0 to a, sorry, from 0 to a. Okay, this is not capital A. Let me write it beautifully. Yes, this is from 0 to a. All right, so finally what the things you are going to get? 1 plus iota into a square by 2. Okay, so this is the integral along c3. Okay, and how can you forget that negative sign? You cannot forget that negative sign, okay, which has taken earlier, because the orientation were opposite. So this is the integral along c3. So your final integral will be what? Integral over c, real part of z dz will be what? The summation of c1, real part of z dz, plus integral along c2, real part of z dz, plus integral along c3, real part of z dz. Okay, so along c1 what can you see? Along c1 it were a square by 2. Along c2 what were? A square I, isn't it? So we will write a square iota, but along c3 it will become minus a square by 2, minus a square by 2, and minus iota a square by 2, isn't it? Yes. So this is what? This is a square. So a square by 2 to a square by 2 will be cancelled, and it will become what? A square iota minus a square iota by 2. So it will become a square iota by 2, and this will be your final answer. A square iota by 2 will be what? Your final answer. Okay, so yes, this will be your right answer. So you had seen the picture and everything were quite clear. So now let's go to see some more interesting questions. Yes, what is the next one? Find the value of the integral 0 to 1 plus iota. Okay, 0 to 1 plus iota. So once again they are giving you what? This is your 0 to 1 plus iota means what? 1 comma 1. This is your 1 plus iota, right? You have to integrate from here to here. But follow this path along the straight line. Z is equals to 0 to Z is equals to 1 plus iota. So you have to integrate directly. Z is equals to 0 to Z is equals to 1 plus iota. So what shall you do? Certainly you are moving along y is equals to x in this direction, because this is the line y is equals to x, isn't it? So certainly you can see, if you have z is equals to x plus iota y, if you will have z is equals to x plus iota y, x plus iota y, all right, z is equals to x plus iota y, then along y is equals to x, your z will become what? X plus iota x, isn't it clear? Yes. And what will you say about your dz? Your dz will become 1 plus iota dx. Isn't it clear? Yes. 1 plus iota dx. This will be your dz. Alright. So yes, this way the thing. dz is equals to 1 plus iota dx. Isn't it? So now you have to integrate this first part. So we are going to write all these substitution over there. Then what the thing you are going to get? Integration from where to where? This is 0 to 1. Okay, because we are converting everything in terms of x. So you are going from 0 comma 0 to 1 comma 1. So you are going to convert everything in terms of x. So the limit of x is what? From 0 to 1. This is the limit from 0 to 1. Okay, so yes, so that's why we had taken that. And thereafter you can see what? Here is x, here is minus y. So it will become x minus x and plus iota x square. Alright. And dz is what? What is your dz? Your dz is 1 plus iota dx. Right? Yes. So x to x will be cancelled and you can see what? This is iota x square. So it will become iota x cube by 3. And from where to where? 0 to 1 and 1 plus iota is already there. So finally you can see what? You can see if you will put x is equals to 1, then it will become iota by 3. Iota by 3 and into 1 plus iota. So finally you can see this is nothing but iota and plus iota square by 3. So you can write it as iota minus 1 by 3 and this will be your answer. Okay, now I am giving you a HW, a homework question over here. The same integral, but yes, this kind of question already discussed. So along you have to do what? Along x-axis, first of all you have to integrate along this x-axis. I mean to say 2-step question. From 0 to a you have to integrate and thereafter from a to b you have to integrate. Okay, you have to integrate along c1 and c2. Okay, and this kind of question has already discussed in the very first part, so you can try it. Otherwise in the next class or in the next part we will come up with the solution of this part. So this part is your HW. You may put your answer in the comment as well. Okay, so we'll meet in the next part. Till then, take care. Bye bye. Thank you very much everyone. And certainly we will discuss some more interesting line integrals, and after that I will introduce you with the contour and some more integrations, and thereafter we'll start Cauchy theorem, Cauchy integral formula. Okay, Cauchy integral formula for higher derivatives and everything. Okay, so you can subscribe this channel, you can share this channel, and we will meet in the next lecture. Till then, take care. Bye bye. Thank you.